Hi, welcome to our presentation about Movie Magic, a movie database that allows users to be able to rate, store, and share movies with their friends. We plan that this will be a future competitor to IMDb. I'd like to take a second to introduce the team. My name is Kyra Murphy. We also have Porter Lovelace, McKay Moulton, Bryson Barrow, and Hannah Southwick as well. This is a screenshot of our application. Not all movies are created equal, but here are some of the better ones. For our business case, we anticipate about 2.4 million daily visits to our website. This means that we really value low latency and speed for our users. So the solution we thought up was a completely cloud-based solution with built-in scalability and automatic deployment through AWS. This way we'd be able to provide these services to our users in a scalable way. So I'm going to show us our diagram. So the first thing we'll notice is we're in the Ohio region. We have a VPC within that has two security groups and that are associated with two subnets as well. We have a front-end subnet, which is a web server that is hosted on port 80, port 43, and 22, and a back-end subnet that hosts Amazon RDS, our database, with port 3306. In our diagram, we account for multiple availability zones too, with the potential for auto-scaling of the EC2s within them. So if I were to take you through the role of a general user, they would hit our website through an elastic application load balancer. We've accounted for 5. For our users, we actually anticipate there to be about 25,000 concurrent users at a time, which would then account for the 2.4 million daily users. The application load balancer basically would then direct the traffic to each, and so that each user has equal opportunity to be able to see our website. From the role of developers, you'll notice that they are able to push code through Visual Studio directly into a code pipeline. And this is really cool because the code pipeline will then store application in an S3 bucket with other stack resources that we might have in the future, with the possibility as well of using Amazon CloudFront to put it a little closer to our users throughout the United States. After this happens, the code will automatically be published through AWS Code Deploy, and the developers would be able to work on the next features and start the process over. So this is an overview of our diagram. Any further information can actually be referenced in our documentation. Here's our monthly cost of $37,000 for our budget for all of our services that we've provisioned, with a total yearly cost of $444,000. So I'll start with the things that are most expensive and kind of explain why. So Amazon EC2, we actually are going to be provisioning 250 instances of M4 X large. So that would give us about 16 gigabytes of RAM as well as 4 vPCUs to use. We estimated that for one of these instances, they'd be able to support 100 concurrent users at any given time. And so 250 ought to do. For our elastic load balancers, we chose 5 because we estimated that they'd be able to support 50,000 concurrent users at any given time. And we're just under that at 25,000. Two other interesting things to note here for our AWS pricing calculator is we're using Amazon CloudFront, which we haven't built yet in our solution, but is in our documentation for future use to push our website closer to our users, and Amazon CloudWatch, which would give us logs about our usage. All right, now I'll pass it off to Porter, and he'll guide us through some of our AWS console resources and a future demo.
I'm really grateful to Cairo for being able to explain that diagram to us. One thing that he said that I find that's really important is about our instances and the way that they're being used currently. As we look around through our current console, you'll notice that we only have about 1 instance or so per resource, just for the sake of being able to save time and money currently, as we are not fully doing this project, as we are not fully deploying this project to scale as necessary. If we look at our RDS here, we can see that we've got very low CPU usage as well as low storage usage currently, because we are early stages of the website service. We don't have as many users physically actually happening, but we are prepared to scale up and move into those as needed. Again, we can see also, we want to point out that all of these resources have been provisioned via CloudFormation and infrastructure as code, which has been really nice and very useful as we have gotten everything together. You can check in our documentation, our CloudFormation templates as well. So moving forward, we're gonna show you our EC2 dashboard. Like I said earlier, we have the one instance running currently, but that due to elastic load balancing and auto scale, things will scale up quite quickly as we start to obtain more users and such. We also wanted to show off our code deploy, which has been super awesome, maybe our favorite part of this project. We put a lot of time and effort into focusing on this S3 bucket, where when we store applications there, our pipeline automatically notices the differences and will deploy those differences to our web service, which is incredibly useful for developers. We want to show you the actual website and how it's been working and how it will continue to work. And we'll even do a little demonstration with the database. So if we tab over to the web page, you can see, aside from just Wizard of Oz and Forrest Gump, we've got several other classic movies, I might say, that have been rated very well. And we can even sort by rating or year, just to be able to have a little bit of variability. But we wanted to show off to you, we have a connection to our RDS instance, and we're going to insert a movie, the movie Avatar. So after we do the insertion, we can tab back to the web page, and after a quick refresh, you can see that the dynamic web page will display our updated database, which will make it perfect for users to be able to share with their friends and be able to access different ratings, and is a future competitor in the industry we know very well. It's been a very wonderful project, and we're going to be able to pass on the torch to Hannah, who will be able to talk about our team retrospective.
Thank you, Porter. I wanted to also mention two of our other team members who are not on this recording. We had Bryson Barrow, who worked on the CloudFormation as well as the code pipeline, and then we had McKay, who worked on the initial site development as well as the RDS connection. Cairo, who spoke to us at the beginning, worked on the cost estimation, and Porter spoke just barely, and he worked on CloudFormation as well. My name is Hannah, and I spent the majority of my time working with the diagram and the code pipeline. So in the conclusion of our project, we conducted a team retrospective, which highlighted the successes as well as challenges of this project. We noted that the majority of our challenges stemmed from the lack of resources, time, and our experience. As part of those challenges, we noticed that the deployment log debugging took a lot of time and could have also been solved with a little bit more time or more knowledge in that area. ASP.NET research was a pain point for us as well, considering we did not have a lot of experience with deploying ASP.NET applications in AWS without the use of Elastic Beanstalk. Elastic Beanstalk would have been another alternative for us to use throughout this project. And in terms of experience, since we're not professionals and we did not have access to an AWS professional, this added more time as we need to research and debug a little bit more. We recognize that most companies have appointed AWS professionals who are there to kind of help with the debugging and additional challenges that they may face. So this was a new experience for us as a team working with AWS infrastructure, and the majority of our AWS knowledge comes from coursework as well as class lectures. And so we dedicated a lot of our time to learning by ourselves and asynchronously. We were able to do a lot of cool things just through our own knowledge and research, and we had a good time with this project. AWS provided us with the means, and we didn't experience any limits other than just time and available research. So some of the solutions to our challenges would just be more research, because research provides us with experience and as well as time to be able to complete a grander scope of this project. So Thank you so much for your time. If you have any questions, you can refer to our documentation, which includes our lucid chart diagram as well as our CloudFormation template.